In this video, we are going to talk about how to graph this function, which is a transformation of the function y equals cosine of x. And to do that, we are going to utilize this paradigm, which will help us set up our parameters. The first thing we want to do is establish the amplitude. And the coefficient out here in front of the function is the amplitude. Specifically, the amplitude is going to be the absolute value of that coefficient because the amplitude always has to be positive. The amplitude is going to refer to the distance from the middle of the graph to both its minimum and maximum. So the middle of the graph is also known as the horizontal axis of symmetry. So the amplitude is going to be this distance that is from the middle of the graph to its maximum and from the middle of the graph to its minimum. The second thing we want to do is establish the period of this transformed function. And to do that, we're going to use this coefficient, b. We're going to take the period of the parent function, which as you know for cosine is 2 pi, and we're going to divide that by the absolute value of the coefficient b. So in this case, it's going to be 2 pi over 2 and a period of just pi. And this makes sense because if you look at this function, cosine of 2x, the way I think of it is that it is traveling twice as fast as the parent function. So if the parent function takes 2 pi radians to complete a cycle, one that is traveling twice as fast is going to do it in half the time. So now that we have our amplitude and period, the next thing we want to do is explore any phase shifts that are present. And because this coefficient c is non-zero, there is a phase shift. Now I've seen this formula written as both plus and minus c, but as you'll see in a moment, it really doesn't matter because the best way to find the starting point of the transformed function is to set whatever's in the parentheses, in this case 2x plus pi over 2, equal to 0. We are now going to solve for x, and that'll give us the starting point of this transformed function. So if we solve for x, we're going to have negative pi over 2 divided by 2 over 1. We're going to use keep change flip. We're going to flip this fraction and turn it into a multiplication problem. And our final starting point is going to end up being negative pi over 4. Next, we want to find the ending point. Now, there's two ways to find the end point. The first is to take the starting point of this transformed function, which we know to be negative pi over 4, and we add the period of this transformed function. Okay, so now we are finding the end point. We're going to take the starting point of this transformed function and we're going to add the period. We're going to rewrite pi as 4 pi over 4, and our final ending point is going to be 3 pi over 4. Now the other way to do that is to take the original ending point and set that equal to what is in the parentheses. So recall the original ending point of the parent function would be 2 pi. So now we would solve for x. The way I would do this is to blow this up by multiplying everything by what's in the denominator. So I would multiply everything by 2 to get rid of that fraction. I would now have 4x plus pi equals 4 pi. That will simplify to 4x equals 3 pi, and x equals 3 pi over 4. So you see you do get the same answer regardless of the way you're determining the endpoint. Next, we look at the d-value. The d-value represents any vertical shift. in the middle or the horizontal axis of symmetry of the function. So in this case, our function is going to be transformed or translated vertically in the -2 direction. Therefore, while the normal cosine function has a middle of the x-axis where y equals 0, our new middle is going to be down here at y equals -2. So this entire graph is going to be shifted 2 units in the negative direction. Now that we have our parameters established, we are going to go ahead and graph this function. The first thing we want to do is establish the horizontal axis of symmetry, or the middle of the graph. And recall that was going to be y equals -2 because of this vertical shift that is noted. The next thing we do is establish the maximum and minimum by using our amplitude. Our amplitude represents the distance from the axis of symmetry to the maximum. So if we add 3 units to -2, we would be at, that's +1. And if we then subtract 3 units from -2, we will be at -5. So our minimum and maximum are going to be -5 and 1 respectively. Next, I want to plot the points along the x-axis, along the input axis. So I'm going to begin with the starting point, which recall is going to be -π/4, and our ending point is going to be 3π/4. And then I break this distance here into fourths, and we'll see why I do that in a moment. So to look at the middle between -π and 3π/4, I would basically take the average. So this ends up being 1π/4. So the middle between those 2 points is going to be +π/4. I'm next going to take the middle between the starting point and the midpoint, and if you add pi and -π, you get 0, and you divide by 2, you get 0. So that's going to be an input point, and then we're going to take the middle between π/4 and 3π/4. If you add 3 plus 1, you get 4. You divide by 2, you get 2. So we have 2π/4. So these are the points of interest. Now, folks, if you look at the cosine function, the parent function, you could see that it starts off at its maximum point. Then 1/4 of a period later, it's in the middle. Another 1/4 of a period later, it's at the minimum, back to the middle, and to the maximum. So what we're going to do here is we are going to start at the maximum position, but we're not going to start at 0 because we have a transformed function, a phase shift. So we are going to start at -π/4. So at -π/4, our transformed graph is going to be at its maximum, which is going to be +1. If you're not sure about that, if you're not sure where to start, feel free to plug in values. So if our starting point is -π/4, and we plug this in for x, and we do the algebra, we find that the y value is going to be +1. And indeed, that is the maximum point of our graph. Okay, now for the second point, recall that the cosine function goes from the starting point, which is its maximum, to the middle. So we're going to go to our transformed graph and place our next point in the middle, which is right on the axis of symmetry. So here our input value is 0, that's our second point, and the output is going to be in the middle of the graph, which is at the horizontal axis of symmetry, or y equals -2. Folks, again, if you're not sure where to put that point, here's our second point. We're plugging in x equals 0. When you do the math, you end up with y equals -2. And recall, that is our horizontal axis of symmetry in our transformed graph. Okay, so now we're at our transformed graph, and we know the behavior of the cosine function. Starts at a maximum, goes to the middle 1/4 of a period later. Then it goes to its minimum point. So at pi over 4, it's going to be at its minimum, then back to the middle, and then back to the maximum. So folks, here is the transformed graph of this function. I went ahead and graphed this on a calculator, graphing calculator, Desmos. So here we go. -2, that is our horizontal axis of symmetry. Here it is with this blue line. Next, we establish our amplitude. Our amplitude is 3. Therefore, we're going to add 3 to -2 and establish a maximum of 1. And we're going to go 3 in the other direction to establish a minimum of -5. We're then going to use this coordinate, the 2, to establish our period. When you divide 2 pi by 2, you get pi. So our transformed graph is going to have a period of pi. We next use what's inside the parentheses to establish our starting point, which is -pi over 4, and our ending point. We plot every 1/4 of a period. Next, we look at our parent cosine graph, which we know to start at a maximum. 1/4 of a period later, it comes to the middle, which in our case is -2. 1/4 of a period later, it goes to its minimum, then back to the middle, then back to the maximum.